Hey everyone, so here's the video that I promised for the first worksheet we did this week. And on this one we're finding, well, this section actually is dealing with interior angles of a polygon. Okay, and this formula right here is the one we'll use for this entire page. Now that gives us the sum of the measures of an interior angle. Okay, and actually that's what we need to find for number 1, 2, and 3. And remember on that table that I gave you guys that I asked you to print or write down in your notes, that lets us know that a hexagon has 6 angles. So if I want to find the sum of the measures of the interior angles of a hexagon, I take the 180, n minus 2, and instead of n, I put in how many angles the polygon has, which is 6. And then just type this into the calculator, and you get 720. So for a hexagon, the 6 angles add up to 720. Okay, and then a decagon has 10 angles in it. So again, I'm going to start off with the formula, and instead of n, I put in 10 because a decagon has 10 angles. Type that into the calculator, and then we get 1,440. So again, the 10 angles in a decagon equal 1,440. Okay, and then these ones that really don't have name, 20gon, again, I kind of like those because that right off the back tells me how many angles there are. There's 20. So then I just type this into the calculator, and we get 3,240 degrees, right? So for a 20 angle polygon, if you add them all up, you get 3,240. Okay. Oh man, it doesn't show it. So then the next ones, what we have here is we want to find the missing angle. Okay. So the first thing we have to do is find the total of the angles inside the polygon. Now this polygon has 1, 2, 3, 4 angles in it, so I'm going to let n equal 4. And then when I figure out the total, or type it into the calculator, the total is 360. So I know if I take 360 and subtract out the angles inside the polygon that I know, minus 120, I'm left with the value of the missing angle. Okay, so that would be 102. Okay, why that missing angle up there is 102. So same thing with number 5. The first thing we need to do is figure out the total sum for this polygon, and this polygon has 1, 2, 3, 4, 5 angles. So because it has 5 angles, I know if I were to add all these angles up, I get 540. Now to find the one that's missing, to find the value of x, I take the 540 and I start to subtract out the angles I know. And then what I'm left with is the value of the missing angle, which is 103. So we know x equals 103. So same thing with 6. First we have to find the sum of the angle measures. So this one has 1, 2, 3, 4, 5, 6, 7 angles. So type that in the calculator and we get 900. So I know those 9 or those 7 angles have to equal 700. And then I just start to subtract out the ones I know. And the one we're left with is the one we're looking for. So let me just go ahead and write it. So once we do all that subtraction, we get 145 degrees. Okay. Oh, let me scoot that over so you can see it. And then the next one, the next set of questions, this one says, find the measure of an interior angle of each of the regular polygons. Okay, so I know because it's a regular polygon, all the angles and all the sides have the same, have equal measures. Now again, from my table, a pentagon I know has 5 angles. If I find the sum of the measures for the pentagon, I get 540. Now if I want to figure out how much one angle equals, I need to take that 540 and distribute it between 5 angles. And that's pretty much means to divide. So I know one interior angle equals 108. For a pentagon, for a regular pentagon actually. And then for a regular dodecagon, well, dodecagon has 12 angles, so do 180, 12 minus 2, type that in the calculator and you get 1800. Take that 1800 and distribute it amongst the 12 angles. So when you do that, you get 150. So for a dodecagon, one interior angle equals 150. And then for an 18gon, I know there's 18 angles, so I substitute that into my formula, and the 18 angles together add up to 2,880. If I want to figure out how much one angle equals, you need to divide that by 18, and you get 160. So one interior angle equals 160. Okay. And then for the last one, they give us what the sum of the measure of the interior angles equals, and what we have to do is figure out how many angles was that, or how many sides was that. So basically it looks like this. We know what the formula is, and we know what it equals, but what we don't know is what number we plugged into that formula. So what we need to do is solve for n. So the first thing we do is divide both sides by 180, and when you do on the left hand side, you're left with n minus 2. On the right hand side you have 6, and then finally to get n by itself you would add 2 to both sides, and then you have n equals 8. So I know there are 8 angles in a polygon that has the sum of the interior measure angles 1080. For this one, again, same thing. Take the formula, and then whatever number we put in there, that's what we're looking for. I know it equals 1,440, and 1,440, to figure out n, again, first you need to get rid of the 180, so you divide by 180, and when you do, you get 8, then add 2, n equals 10. So I know that polygon has 10 angles. And then for the last one, the sum of the measure of the interior angles is equal to 1,980. Divide both sides by 180. That is 11. Add 2 to both sides, and we get 13. So again, I know that polygon has 13 sides, or 13 angles.